In this video, we are going to discuss how to find the area of a triangle. So we're used to the formula area of a triangle equals 1/2 base times height. But when we're talking about that specific formula, we have to have either a right triangle, where this guy would be the base and this guy would be the height, or we have to have some other triangle where we have what's called the altitude. The altitude is a line that's dropped from the top and it's perpendicular to the base, so it creates this right angle. But what if we don't have that altitude? How can we find the area of a triangle? And notice in this section, they're using area as a K instead of an A. So that's what K is going to represent here. Well, for something like this, it's easy. It's going to be one of these two scenarios. We have the height, but if we don't have the height, we can still find the area if we have something kind of like this, where we know side A, side B, and we know angle C. Okay, so an example of that would be like example 8. What if we have that? We can't use 1/2 base times height because the height would actually be this guy. And could we find it? Probably, but it would take a lot of work to be able to get there. But we do know a few things. So we know that this is angle C. We know this is side A, and we know this is side B, and we can use this formula to do that. So notice that the angle has to be between the two sides that you know. And depending on the angle that you have, you may have to tweak the formula a little bit to use one of these two formulas, but they really do work the exact same way. So how would we apply this formula? K is going to be equal to 1/2 AB sine C. So our A is 2, our B is 5, and we need to find the sine of 20 degrees. So I'm just going to simplify this a little bit. This is 1/2 times 2 is 1. 1 times 5 is 5. So this is 5 sine of 20 degrees. And then we're going to go to Desmos and we're going to type that in. Let's make sure we're in the correct mode. I'm going to go over to my, move this a little bit. And we need to be in degree mode. So when I put that in degree mode, this would be my area of that triangle, 1.71. So I'm going to say approximately equal to 1.71. All right, so let's do another one. Let's look at 17. So we're going to draw a picture of what we have for 17 first. So just a random triangle, A, B, and C. So this would be side A, this would be side B, and this would be side C. They're telling us side A is equal to 3. They're telling us side C is equal to 2. And they're telling us B is 110 degrees. So you can see how B, once again, is the angle between the two sides that I know. I know side C and I know side A. So I'm going to go back to my formulas. I know sine of B. So there's my formula that I'm using. Let's substitute in what we know. A is 3, C is 2, and we're looking for the sine of 110 degrees. So 1/2 times 3 times 2 is going to be 3. Going back to Desmos, we're going to need, 3 times sine of 110. And we're still in degree mode. So here is my side, about 2.82. And since we're talking about area, that would be squared units. We don't know the units. I'm just going to call it unit squared. I could have done the same thing up here for unit squared. Okay, now, what if we don't have any angle? Well, we can use Heron's formula to figure out the area. And Heron's formula says it's going to be, area is going to be equal to the square root of s times s minus a times s minus b times s minus c. S is 1/2 of the perimeter, okay, which is the distance around that triangle. So if we look at 9, we don't know an angle here, so it's going to be easier for us to apply Heron's formula. So we're going to start by finding S, and I'm going to use that cursive S, so it makes it clear that that's not a 5. So S is going to be 1/2 of the sum of the sides. So I'm labeling everything here, sides A, B, and C. So it's going to be 1/2 of 6 plus 5 plus 8. So 6 plus 5 plus 8 is 19. And 19 divided by 2 is 9.5. Okay, since that's a nice decimal, by nice I mean it ends, it's just one decimal place here. I'm going to use that decimal. If this were not a nice decimal, so maybe we were dividing by 3, we would keep that as a fraction. So then Heron's formula says k is going to be equal to the square root of 9.5 times 9.5 minus 6 times 9.5 minus 5 times 9.5 minus 8. So we got 9.5 times 3.5 times 4.5 times 1.5. And I'm just going to do this off to the side on my calculator that's off screen. We could also type it in the Desmos. And when I type that in, I got about 14.98. And since this area is going to be in square units. So if we had another one where we had to draw a picture of it, maybe like in number 20. I like drawing the pictures so we have a visual of what's going on. So side A is 4, side B is 5, and side C is 3. We got to find S first. S is 1/2 of the distance around. So 1/2 of 12, which is 6. And then Heron says it's going to be the square root of S times S minus A times S minus B times S minus C. So square root of 6 times 2 times 1 times 3. So 6 times 2 times 3 is 36. And square root of 36 is 6. So this would be 6 units squared. Okay, let's look at a word problem. I said we want to find the dimensions of home plate. They're asking us to find the area. So they've given us the dimensions. So I'm going to divide this into 2 different figures here. So I've got a triangle up here, and we know that this is going to be 17 inches for that base of that triangle because the bottom of this pentagon, which is a 5-sided figure, is 17. So I'm going to call this area 1. I'm going to call this area 2. So area 1 is a triangle, and we could use Herons. So S is going to be 1/2 of 17 plus 12 plus 12. Which is 1/2 of 41. Now, I'm having difficulties with my pen. 41. There we go. So 41 divided by 2 is 20.5. So the area of the triangle is going to be square root of 20.5 times 20.5 minus 12, 20.5 minus 12, 20.5 minus 17. So I'm going to do that computation off to the side on my calculator. And when I did that, I got 71.99957. So that's really close to 72.0. Now, area 2 is a rectangle. And to find the area of a rectangle, it's base times height. So for that area, it's going to be 17 times 8.5. And 17 times 8.5 is 144.5. So my total area would be when I add those two together. So area total is equal to area 1 plus area 2, which is going to be 72 plus 144.5. So 72 plus 144.5 would be equal to 216.5. And once again, that is in square units. And this time they gave us a units. They're telling us it's inches. So the area of home plate for any Major League Baseball stadium is going to be 216.5 square inches.